Hello. Okay. Hi everyone. So welcome to this week's webinar. Last time we talked about the image classifier project, and I guess last time we talked that this would be the last webinar on that project, and from now on we'll be moving towards the unsupervised learning part. So the unsupervised learning part is the last module of your term one nano degree, and it is comparatively smaller than the previous part, that is deep learning. So for this part also you have to submit a project, and for that project you have to work on a Jupyter notebook, just like the previous one. And in the first project also you worked on a Jupyter notebook and saved that, submitted that code only. Here also you will be doing something similar. I'll run you along through the project later, and then we will discuss the several parts of the project also, and what is the timeline of the project. And let me tell you that the nano degree term 1 will end on July 4th. And so if it's not the case, maybe you can check it. Maybe many of you started a little earlier, but I guess this batch started on 26th of March, so this was scheduled to end on 4th of July. And after that you get an extension of 1 month. So for those of you who are thinking that maybe they are lagging behind, or they have not submitted previous projects, or maybe they got some feedback and they are working on that, so they have 1 month more to work on the projects and submit all of them on time. So this next project is not that long. Maybe this deep neural network project, the image classifier, was quite long, but this one is pretty doable in short amount of time. Just make sure that you attend all the lectures of unsupervised learning, so that would be a plus. Apart from that, all the minor code segments that are to be used in the project, we will discuss them through the webinars. So what you can do is you can attend all these webinars, watch the videos, and try to follow through the code of the webinars, that is the code segments that I'll be making. Use those code segments as it is in your project, and tweak some changes here and there for parameters and all those things, but basic template will be the same. So that way it would be quite helpful for you guys to complete the project. And so yeah, that's it. So now maybe I'll share my screen, and then we can discuss about the project. And then we'll be developing a minor code segment for PCA, that is principal component analysis, which is also the topic of today's webinar. So PCA is the quite important part in this submission of your project. So after data pre-processing and scaling and all those stuff, you will be needing PCA to do the visualization and reducing the dimensions of the data. We will talk about it in a while. So first, let me share my screen, and then we can discuss the project first. Okay. So I hope everyone is able to see my screen now. So this is the project. So maybe just first let's go to the introduction part, right? So the data is available through the AZ Direct and Ervito Financial Solutions, and it contains the demographic information about the people of Germany of a mail order sales company, right? So for this data specifically, you need to submit the work on this project workspace only. I'll suggest you guys to work on this project workspace through Dacity only. Maybe you can avoid downloading the Jupyter notebook and working on your own system, because the company is bounded by the legal agreements that if any of you uses the data, then you will have to delete that data from your system. So kindly take that into considerations. And also then you can see the rubric of the project, and make sure that you understand what all steps you need to complete in the project submission, so that you get all the steps covered and get good marks, or the project is accepted. So for this, you need to install these things: NumPy, Pandas, Sklearn, Matplotlib, and Seaborn. So Seaborn is just wrapping around of Matplotlib. So this you also have to install. This makes the graph from Seaborns are pretty colorful and pretty good. And so about this project, the project is containing the demographic data of people of Germany, and it is a real life data, so it will be a really good experience for you to learn something. uh, until now we were working on the data that was developed or that was generated for the for these kind of works like research based purposes. It did not really had the impact or the usefulness in the real life data, but in this project we are working on the real life data itself, so we will get to know when you go into the industry how vast kind of data is available to the people working in data science, and how do they make out meaningful information from that data and apply different machine learning techniques that we learn from this course. Okay, so the data has following files: Audacity SDR subset. So it contains the demographic data for the general population of Germany. And this is the pin code, I guess. Uh, no, this is not the pin code. This is the number of people. Okay, so this is around 8.9 million, zero point 0.8 million. Okay, zero point 0.8 million data, and these are 85 features. Uh, So these are different attributes for those people. So for each person, we have 85 different attributes, and then there is Audacity customer subset data of a mail order company. It also has around 1.9 million people data and 85 features for each person. Then there is data dictionary that contains the information about the features, and then SDR's feature summary, and then a Jupyter notebook where you will be working to complete this project, right? So first part will be the pre-processing. We have learned a lot about pre-processing in the first module, that is supervised learning. You will also be learning about pre-processing in the unsupervised learning module. So please go through the lectures once, and then you will be able to work on the pre-processing part of the data. So all the hot encoding, one hot encoding that we learned, and all different kind of techniques, those will be useful here, right? And then there is feature transformation. So for every machine learning problem there are always three steps. So first is pre-processing, second is feature transformation, and third is applying the models like learning. Okay, so in feature transformations you will be doing different things, and one of them is PCA that we are going to discuss today, and all the other things that we needing in this project that we will understand after we go to the project. In clustering techniques, you will be using k-means. We already have done k-means in one of our earlier videos. If you can recall that, just go through the video once and you will understand the most of the part of k-means, and then you can code it also here, right? We will be using sklearn inbuilt libraries for all these stuffs: PCA, k-means, clustering, feature scaling, and data cleaning. And then you can compare your project with the project rubric, and then finally can submit it. Okay, and these are the terms and conditions applied under different companies and their data set, and you need to abide by them. So just press next and you will be on the project workspace itself, right? So there will be a pop-up where you will have to accept the fact that you understand the agreement and abide by it. And now are the different segments. So here first you will be loading the data, all the different files that we had, and then this part will be about pre-processing, right? So here you will have to take into consideration the nan values. So nan values you do not actually see in the generated data, but in real life data there are actually many times that there the some columns or some rows do not contain any data. So for that data, for those empty blanks, we call the data as NANs, or and you will have to replace it uh, with the right values accordingly. So you have to identify the missing or unknown data values and convert them to NANs. Then you can care about the NANs later. And then you will have to assess the data. You will have to see how much data varies according to different features. And then after the assessing part, you will go to the feature processing, that is selecting and re-encoding features, and different techniques that we learned, like binary encoding is there, one hot encoding is there. And then once we are done with this, after you complete the feature selection, you will go to the cleaning data part. So cleaning data part uh, is not that hard. You will have to look to the data and remove all those unnecessary rows and columns that you will not be using. Then you can apply the feature transformation. So for feature transformation, first you will have to apply the scaling before applying any feature transformation techniques like PCA, because those are heavily dependent on the scaling of the data. So you will have to first cover it up, and then you can go to the feature scaling part, right? Feature transformation part. So then you apply dimensionality reduction using the PCA. And today we'll be making a small code segment of PCA to understand how does that work. And after you apply the dimensionality reduction, your data from 84 dimensions goes to some 2 or 3 rows that you design for it. And then you can apply your clustering techniques like k-means. And there are different clustering techniques. You can apply all those, and here you will be using k-means, and then you will have to check the performance of that, right? And then you can apply, compare your data with the customer's data to confirm how much your clustering is, how good your clustering is performing. So yeah, that's pretty much all about the project. So in the next part of the webinar, I'll be making small segments of all these projects, and I will try to run it to show you guys how the project works, right? So today we have a different task. We'll be running a code for PCA. So here I have developed a Jupyter notebook file for PCA. So here first you need to import these two things, pandas and matplotlib, right? So let's just import them. Yeah, so you this URL, this comes with the scikit-learn dataset. So the iris comes with the sklearn dataset, and we are going to import this from the sklearn only, right? And yeah, so just maybe then we can apply we can just load the dataset. Okay, so load the dataset. And how do we load it? We You may remember that we use data frame from pandas to load the data set. And ed.recsv, we gave it URL, and then we can give the some names to the columns, right? So we already know the different names for the iris data set. The columns are basically the sepal length and width, the petal length and width. We already had discussed this in few of one of our earlier videos, so you may refer to them. And then we go like this. We are giving them different column names: sepal length, sepal width, petal length, petal width, and then target. So target is the classes of the flowers. So that is something that we know in in supervised learning part, but in unsupervised learning we have to define the classes ourselves. So we have to group the data, the cluster it, and then see which kind of groups are there and what names can we give to them accordingly, right? So you will also need to scale the features in your data set before applying PCA, as PCA is affected by the scaling of the features. So I'll be using standard scaler, which is another functionality from sklearn, to standardize the datasets features into unit scale. So with unit scale, I mean to say that the mean is 0 and variation is 1. And then we apply the same formula that we used, x minus mean upon variation, right? A standard deviation. Okay, so now then let me just import the scaling the features. Let me import from sklearn dot pre-processing import standard scalar, and then we do sepal length. So we are giving it different names. So just so that it knows which features we are talking about, right? So that would we have to save those features. So we can just copy paste it from here, right? And now we can separate the features. We apply the location variable, so we know we are talking about all those features and the values of them. Now we have separated all the features, and now we talk about the target part. So we can remove the target part from the features, right? And then we do fit transform. So you do not need to be worried about that. You can just Google standard scalar, sklearn, get to that. You will see that we are just for this standard scalar use the same formula that we always use, mean upon standard deviation, and then we fit the data to it. So in our case, the data is X, that is all the features. So we'll be just fitting that, and let's run it. Okay, so it says, okay, so sklearn it is. Then again, what did we miss out this time? Okay, standard scalar is right. Reprocessing with standard scalar, better width target. Oh no. So target is not there. The data only contains the feature and column names. So now it works fine, right? Okay. So about PCA. So PCA is basically the projection of your data to 2D or any number of any hyperplane that you want, right? So if your data is like say 100 features long, it is very hard to imagine it in a two-dimensional manner. So we can only imagine the data up to three dimension. After that, the number of dimensions are hard to visualize. So for that we have PCA. So PCA checks the variation of the data in principal main dimensions. It reduces your whole data to a specified number of dimensions, and then you can visualize your data to those particular dimensions. So generally we do it for two dimensions. Like if you have hundreds of features, not hundreds, but if you have a sufficient amount of features, we reduce it to say two number of features, and then we can visualize it on 2D, right? There is a specific good amount of data loss, but you see we take only the highest uh, the components with having the highest variation of the data, so we cover up most of the data in itself, right? So if we talk about the iris data set, it has its original data has four columns. Now we will be reducing it to two dimensions. And after dimensionality reduction, there is no particular meaning assigned to each principal components. There are just two dimensions of variations, right? So you can say that this is dimension 1 or this is dimension 2. You cannot say that after, let's say, it had 84 indices like we have in our project data set. So you cannot say that it had 84 features and I am reducing it to two features. So these two features are first two features and all other rest of the 82 are removed. No, it's not like that. These two features are totally different from those 84 features. These are two different kind of features which are perpendicular to each other, and they can be plotted in the data along, can be projected along these two dimensions and then can be projected in the 2D data set. So yeah, so now we can go to the PCA part. So if I go PCA scalar, you can see the decomposition PCA. For that, we'll be importing it from here, right? So here you can see that they are taking a data set and they are trying to reduce it. So just our data set is a little bit different, so our implementation would be quite different, not that much. Okay, so let's make an object for the PCA class. Let's see. And components ca dot fit transform. Okay, so now we have principal components. Our data is fitted into this PC object, and now we just have to use these principal components and make an object for our principal or now converted data, and then we can use that converted data with our target feature. So let me name it as principal data frame. So principal data frame contains like PD data frame. So we are generating a different frame for now. And so data contains the principal component that we just got. And then we define the columns. Right. So these columns names you can have anything like X and Y, but these are not actually X and Y. So let's just define it as principal components. One principal components, two, right, and then it is finished, right? So now we have take the data, we transform it into principal components, and then we generate a new data frame and put that original data into that data frame, right? And now just concatenate our new data frame with the original target features, right? So with this y, we had this y, and now we'll just be using this features column in our new data frame, right? So its name was target, and then we do this, right? So this will be it. Our data is now reduced to different features, and now our final df is ready, right? So if I write final df, so you can see that here is my first principal component, here is my second principal component. If I load it here also, you can see the difference, right? So, df. Now let's compile it, start here. You see there are four columns and a target associated with the flat data set, and now we apply the PCA, and there are only two columns now, right? So we reduce these four columns to these two new principal component columns. So our now data set is reduced and is plottable in two-dimensional. So why not just plot it and see for ourselves, right? Plot the data, and you need to take into consideration this code because you will be using similar kind of things in your project, right? So for processing the data, I guess we now are already habitual of using the same techniques. We make the plot.figure, and then we define the fixed size. I generally use 1010, maybe then use 88, and then we fig.add subplot one. Okay, x dot set x label. Then we give the names. Head principal components. We have the same names. Principal components 1 and principal components 2. Okay, so these are all small. Principal components 1. Okay, so we have this much. Okay. And now we make one for this. Let's say font size is 59. Okay. And now the title, XY and title, that's the pattern we follow. Right. Title. See. Right. And font size is 20. Now we set the target. Okay, so the targets has these three different class names. So maybe this we need to use. Iris setosa, Iris versicolor, setosa, Iris virginica, Iris versicolor, Iris versicolor. These are the original names of the dataset. Targets or classes. Iris virginica. Right. And now we set the colors. Target, color, and zip. So we combine them using zip colors. Right. Prices to. Let's use camel casing here. DF target. Scatter. Okay. Principal components one. Right. Make the same thing here for it. Right. Same thing here for principal component. It's done. Just need to plot the legend, and now we can show the. Ah, it's not quite the case. Okay, let's see. There should be two separate classes. The green color, the red colors are also there. Okay, maybe we are missing something. Colors are RGB, Satosa was color, Virginica, plotted figure, 8, 8. safety. Mhm. That's one and two. Safety color. Why are they not different colors? They should be red, green, and blue. Ah, get it. Spelling mistake. Yeah, now it's okay. So for target, I did not use the correct spelling, and maybe here also I'm not using the correct spelling. Components. Okay. Yeah, so you can see three different classes have three different colors: red, green, and blue. So this is how the data look in two dimensions. So you see this is now quite easy to differentiate the groupings here. The red one is from one group, the green one is from one group, the blue one is from one group, and now it is easy to visualize how to cluster it. So that forms a very important part of your project, and you will need to make sure that you apply PCA quite accurately. And before that, you need to do scaling that we did here. Okay, using standard scaler, you can use any scaler, min max scaler, or any kind of scaler that you want to use. And then there are other different parts of the project which we'll be discussing in the next class. So I'll completing the project side by side along with you guys. So I'll be covering the pre-processing part and all those parts later. Till then, you can focus on your video lectures and try to make a good understanding of try to get make good understanding of the unsupervised learning part. And then in the meantime, I guess you have this 1 month uh, with you, the whole July month, to cover complete all the rest of the project. So many of you have submitted second project, and some of you are still struggling with it. So you can connect with me through one-to-one calls. My schedule is already available on Calendly, and then we can help each other out in completing the second part of the project. And then you can really code. Even if you are stuck with that, you can start doing the lectures of unsupervised learning. These are not too many, and you will be able to complete it on time. Okay, so that was all for today. We'll be discussing the rest of the module in the upcoming weeks. Okay, so see you next time.